Hi, question number 1 taken from June 2015, Advanced Level Maths Probability and Statistics. The lengths, question number 1, in meters of cars in a city are normally distributed with mean mu and standard deviation 0.714. The probability that a randomly chosen car has a length more than 3.2 meters and less than mu meters is 0.475. Now we need to find mu. Okay, 4 marks for this question. Right, so what are the information that we have? And okay, all right, so let's take a look here. Question number 1. Now we are told that x is normally distributed with a mean mu and standard deviation of 0.714. Now, and also that a randomly chosen car, the probability that a randomly chosen car has a length more than 3.2 meters. So we would say then probability of x being greater than 3.2 meters, all right, and less than, okay, and probability of x being less than the mean mu, all right, is both of that is going to give us 0.475. Now what do we make here? If x is greater than 3.2, then it means basically that the probability of 3.2 being less than x, and at the same time x is less than the mu, so less than the mu, and that is going to give us 0.475. From here, what do we do? Of course, we can take the probability of, this is greater than this one, so the greater value minus the smaller value, isn't it? X is less than the mu. Alright, so we're going to say, therefore, the probability of x being less than the mu minus the mean mu divided by the standard deviation, okay, over the standard deviation, which is 0.714, and that is, alright, that greater value minus the smaller one, minus p of x. If 3.2 is less than x, then x is greater than 3.2 minus the mean mu divided by the standard deviation 0.714, and that is going to give us 0.475. Now at that stage we need to standardize. Mu minus mu is 0. 0 divided by 0.714 is 0. So we're going to say the probability of z being less than 0 minus, what about this one? This is exactly the same as 1 minus the probability of z. Instead of saying greater, we're going to say less than 3.2 minus the mean mu over 0.714. And all of that is going to give us 0.475. What do we make of this? This is xi of 0 minus, in brackets, 1 minus xi of this whole thing here, 3.2 minus mu divided by 0.714, and all of that in brackets, alright, is going to be 0.475. Again, what is xi of 0? Xi of 0 is going to be 0.5, isn't it? From your table of values you can find that. Minus 1, minus becomes plus, and also we have a xi of 3.2 minus the mean mu divided by 0.714. That is going to be 0.475. 0.5 minus this is going to give us minus 0.5 plus xi of 3.2 minus the mean mu divided by 0.714 is equal to 0.475. Okay, and when this goes on the other side, becomes positive, So now xi of 3 decimal 2 minus the mean mu divided by 0.714 is going to be 0.475 plus 0.5. Okay, if we have to add these, that's going to give us 0.475 plus 0.5 is going to give us this much, 0.975. Okay, so that's 0.975. Okay, and what do we make now? So that xi of 3 decimal 2 minus the mean mu divided by 0.714. If you take this one on the other side, becomes the inverse of the other one. So 3 decimal 2 minus the mean mu divided by 0.714 is equal to the inverse of xi 0.975. And okay, so what is this one from your table of values? Now from your table of values, this is going to be, okay, so I'm going to take the inverse of that. Here we are. 0.975 is going to give us 1.960. So 1.960. I'm going to say 3 decimal 2 minus the mean mu over 0.714 is equal to 1.960. Now at that stage we've got to be very careful here. Okay, there is a minus here, minus the mean mu. Okay, and previously, so what do we make if this times this? Let's take a look. What is this? This is a negative value or a positive value? Okay, so if we have to sketch the normal distribution curve, I think we're dealing with some sort of minus here. Yeah, this would be minus then. Okay, we'll come to that and confirm this value later on. So for now, let me be content with this. Okay, so I'm going to say minus 1.96 multiplied by 0.714. So this times this is going to give us 3 decimal 2 minus the mean mu is equal to minus 1.39944. So minus the mean mu is equal to minus 1.39944. You send this one on the other side, becomes minus 3.2, and you minus 3 decimal 2. So minus the mean mu is equal to minus 4.59944. So the mean mu is 4.60. Does that make sense to confirm that this was negative? If this was positive, what would have happened? We would have never got a value that is as great as this. This is 4.60, and I think it does correspond to the original requirement here. 3.2 less than x less than mu. Therefore mu has to be greater than 3.2. It was great for me to take minus 1, go in the reverse direction in your table. So you will come across, you will be able to do that from your experience. Alright, so here we are for question number 1. Hope that helps.